Hello, Gitanjali ma'am, we can start now.
Yeah, Vinay, I'll start. Vinay, is the screen visible?
Yes, ma'am, it's visible, ma'am.
Hello, Vinay, am I audible?
Yes, ma'am, you are audible, ma'am.
And the screen is visible?
Yes, ma'am, the screen is visible, ma'am.
Okay, how many participants are there?
Only 20.
Okay, shall I start the class?
Yes, ma'am.
Okay, thank you, Vinay.
Okay, ma'am.
Good morning, dear students. Myself, Dr. Geetanjali, working as an assistant professor in the Department of Physics, Bangalore Institute of Technology. In today's class, I'm going to discuss about the chapter Electromagnetic Waves, which is taken from 2nd PUC syllabus. Before discussing the actual topic, let us know a little bit about the importance of electromagnetic waves in our life. Generally, electromagnetic waves are called light. So according to Plato, we can easily forgive a child who is afraid of the dark. The real tragedy of life is when people are afraid of the light. It is understood that a child who is not aware about darkness may be afraid of it. But people who are grown ups are aware about both darkness and brightness. If they are still afraid of light, then the life becomes miserable for them. Because we all know how important the light is in our day to day activities, isn't it? For us, light is life, light is future, light is inspiration. Of course, light is everything for us. We Indians, in fact, treat light as God and worship, isn't it? Dear students, just remember the Sanskrit saying, Tamasoma Jyotirgamaya. Yes, light is a ray of hope. It drives you towards brightness. It shows correct path. So, dear students, you are one of those lights who can illuminate yourselves by doing well in CET and by joining professional course of your choice. Okay, with this general introduction to light, let us now move on to the actual topic. So here onwards, I'll treat light as part of electromagnetic waves. As you all know, sun is the natural resource of electromagnetic waves and it belongs to everyone, isn't it? Nobody can claim sun. Remember, nobody can claim sun. Therefore, it will never create any disputes among people, like just like our Kaveri River. Remember the disputes because of Kaveri River, but sun will never create any disputes because it is belong to, it's everybody's property. So dear students, you have studied in current electricity chapter about Ampere's circuital law, which can be represented by this equation. So it is given by line integral of B dot dl is equal to mu naught I. So where B represents the magnetic field, dl the length of the conductor, mu naught permeability of free space, I represents current flowing through the circuit. So you have already used this equation, isn't it? In order to find the magnetic field due to different element carrying DC, that is direct current. But it fails in case of AC. Suppose if the current is varying, then this equation will not hold good. So therefore, Maxwell, name of the scientist, corrected it by introducing a new concept called displacement current. Remember, students, this displacement current is not included in your CET syllabus. So let us not bother too much about this. So just for the matter of continuity, I have represented that equation, corrected form of this equation. Here the extra term called ID, which is representing the displacement current. So need not have to worry about this equation. So you won't get any questions related to this equation. So during the derivation of above equation, so Maxwell realized that oscillating charges. So what are oscillating charges? They are also called as accelerating charges. So accelerated charges are nothing but oscillating charges which produce varying electric and magnetic field. And these changing fields would propagate from the source in the form of waves. So varying oscillating charges or accelerated charges will be moving with varying velocity. Therefore, they produce changing fields. So they propagate like a wave. So these waves are now termed as electromagnetic waves. Okay. This is how the electromagnetic waves came into picture. That doesn't mean that there were no electromagnetic waves earlier. They were, but we were not aware of them. Maxwell showed that light or electromagnetic wave can be produced by varying electric and magnetic field. So then what are these electromagnetic waves? Can anybody answer what are actually electromagnetic waves? Yes, electromagnetic waves essentially consist of varying electric and magnetic fields in mutually perpendicular directions. So they are represented by second order differential equation as follows. So this is the electric, in terms of electric field, we have given the wave equation. So it is equivalent to mu naught and epsilon naught. So E represents the electric field here. So mu naught is the permeability of free space, permeability, and epsilon naught represents the permittivity of free space. So in order to express the same equation in terms of magnetic field, let's just replace E by B. The same equation holds good. Just replace E by B in order to express the wave equation in terms of magnetic field. So this wave equation is similar to wave equation traveling with velocity V. So hope you can remember that equation. So this is a pictorial representation of electromagnetic wave. So an electromagnetic wave which is propagating along x-axis in homogeneous medium, which is containing variable electric field and variable magnetic field, which is along y and z axis respectively, is as shown in the figure. So the instantaneous values of electric and magnetic field is given by these equations. So E is equal to E naught sine of kx minus omega t into j cap, and B is equal to B naught sine of kx minus omega t into k cap. So here E is for electric field, E is for magnetic field. So E naught and B naught represents the amplitudes. So K is the wave parameter called wave number, and it is given by the formula 2 pi by lambda. Remember this to solve the problems. And omega represents angular frequency, which is given by two pi mu. Hope I'm audible, students. Okay, 2 pi mu. So this is wave number, and this is angular frequency. And x represents the direction of propagation. T represents time. J cap represents the unit vectors. So you know about the representation of unit vectors. So I cap is represented for x-axis, J cap is represented for y-axis, and K cap is represented for z-axis. So this electric field is taken along y-axis, therefore we are represented by J cap, and magnetic field B is taken along z-axis, so it is represented with K cap. This is the directions. Are you following? So this is the magnetic field, which is shown in yellow color, and the electric field, which is showing in green color, which are varying. So these two together are propagating as a wave in positive x direction. So this is termed as electromagnetic wave. As the name itself indicates, it consists both electric field as well as magnetic field. And these three are mutually perpendicular to each other. Remember this. Hope you understood this. Now coming to the properties of electromagnetic waves. You all know very well about the properties of electromagnetic waves, which you have already studied. I have listed here only few among the all properties. So just remember these properties in order to answer the questions. So let us read one by one. So first property says there are transverse wave in nature because of mutually perpendicular electric and magnetic waves. So they are usually transverse in nature. They travel with a speed of 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second in vacuum. So all electromagnetic waves carry energy and momentum. So they undergo reflection, refraction, diffraction, and of course polarization. So photoelectric effect, Compton effect, and wave production are some exclusive properties of electromagnetic waves. So all electromagnetic possess same velocity. Remember this? All electromagnetic waves possess same velocity, but differ in their wavelengths, frequencies, and energies. So all will possess same velocity. They exert pressure on the surface of incidence. It is called radiation pressure. So the energy densities of electric and magnetic fields are represented as shown in the equation. You have to remember these equations. Please remember. So here E represents for energy density related to electric field. So B is there. It is representing the energy density related to magnetic field. So you have to remember. So there is no shortcut for this. You have to remember this formula. So hope you understood the properties of electromagnetic waves. Now let us move towards the actual formulae required to solve the problems related to electromagnetic waves chapter. So first we have the equation C is equal to 1 by root of mu naught into epsilon naught. So this is the velocity of light, velocity of electromagnetic wave when it is traveling or propagating in vacuum, that is free space, where mu naught and epsilon naught represents the usual meaning, like mu naught is a permeability, epsilon naught is the permittivity. So if suppose the electromagnetic wave is propagating in any material medium, then instead of C, you have to represent the symbol as V. Then it is given by 1 by root of mu epsilon. So this is actual permeability and actual permittivity. So you know the relation. Mu is given by mu naught into mu R. Is relative permittivity, the product of relative permittivity with permeability. So this is how it is calculated. So mu into epsilon naught by root of this. So this is when a magnetic wave is moving in a medium. Suppose in terms of wave parameters also we can represent the velocity, and that is given by W by K. It is a ratio of W by K, where W represents the angular frequency, K represents the wave number. Sorry, omega, K represents the wave number. So coming to, in terms of amplitudes of electric field and magnetic field, so the velocity of electromagnetic wave can be written as E naught by B naught. So where E naught is the amplitude of electric field, B naught is the amplitude of magnetic field. So next we have the equation related to refractive index of the medium, which is given by n is equal to root of epsilon by epsilon naught. So this is obtained by assuming magnetic permeability is nearly same. So this can also be represented in different way, that is in terms of dielectric constant, where n is equal to root of k, where k is the dielectric constant. Or you can also write like this, n is equal to root of epsilon r, it is Epsilon r is the dielectric constant, or you can also say relative permittivity. So remember this equation very well, which relates velocity, wavelength, and frequency. So of any wave, it is represented, you know, the very well-known formula V is equal to F lambda. In the same way, in terms of C, we can write it as C is equal to mu lambda. So hope you understood, students. So please remember these equations to solve the problems which are coming later. Yes, now let us move towards the actual part of the topic, that is classification. So classification on the basis of wavelength or frequency, they are classified into different categories, which is as follows. So the whole category is known as electromagnetic spectrum. Remember, there is no clear-cut demarcation between successive categories. Hope the slide is visible. Hope the slide is visible. Please respond, students. Slide is visible. Can you see the spectrum? Yes. Yes, Saujanya has answered. Yes, ma'am. Thank you. Okay. Now look at this. There are different types of electromagnetic waves like radio waves, microwaves, infrared waves, visible rays, ultraviolet waves, X-rays, and gamma rays. So if you look into this spectrum figure, they are arranged. If you go in this way, that is from left to right, then they are arranged in increasing wavelength order. Okay. Suppose if you go from right to left, then they are arranged in increasing frequency, increasing frequency order. So look at this. So in this case, the distance between two plus is very less. That means wavelength is less. Whereas in case of radio waves, the distance between the two waves is larger. So it is more wavelength. So they are around longer wavelength region, whereas gamma rays are around shorter wavelength region. So therefore, from left to right, if you go, these electromagnetic waves are given in the order of increasing wavelength, whereas from right to left, if you go, they are given in the order of increasing frequency. So now here there is a spectrum, visible rays. So WIB-GAIA it is mentioned. So you know about the WIB-GAIA range. It is of the order of 400 to 700 nanometer. So this comes here. So this is the wavelength range given for these electromagnetic waves, different types of electromagnetic waves. Students, there is no other option for this. You need to remember this. You need to remember. So either you have to express wavelength, the range in wavelength order, or you have to express in frequency order. So if you know how to express that in wavelength way, then you can easily convert to express that in frequency because you know the formula C is equal to mu lambda. So with this, now how to remember this classification? So in order to remember this classification, so let us use the trick where I've written just the first letters of those rays. So you remember this as rich, R refers to rich, M refers to man, I refers to in, V refers to visible, U refers to ultraviolet, X refers to X-rays, G refers to gamma rays. So how to remember this? Rich man,
In light.
invisible, you write
X-ray gun. Man in light use.
Vijayanagar. Why I have used Vijayanagar? I will tell you. Used X-ray, you write expensive. So you can make E silent there, expensive. Instead of gamma, you use it as gold. So rich man in Vijayanagar used expensive gold. You know about the Vijayanagar kingdom, you might have studied in history. Vijayanagar kingdom is famous for richness in terms of gold. So that's why I've used Vijayanagar for the in place of V. You can use any city name there, like Venice or Vietnam. So remember that in this way, rich man in Vijayanagar used expensive gold coins or gold. So therefore, R refers to, radio waves. M refers to microwaves. I refers to infrared rays. V refers to visible rays. U refers to UV rays, ultraviolet rays. X refers to X rays. And G refers to gamma rays. Okay. So hope it is understood. And if you go from bottom to up, it is in increasing wavelength order. Hope it's understood. Use this trick. You might have learned different tricks from your teachers who taught you. So with this, now let us move on to, remember this very well. You need this for solving the problems. So let us move on to the applications of electromagnetic waves. So in this slide, I mentioned only the general applications of, major applications of electromagnetic waves, like radio waves are used in broadcasting and communication, like mobile communication. So microwaves are used to cook food. You have heard of microwave ovens. IR regions, which are nothing but the heat radiations, which are used in night vision equipments and also used in TV remote controls. So visible, because it creates a sense of vision for us. So to see the objects, and of course, plants uses it for photosynthesis. UV, which results in pest control and water purification to detect fake currency notes. So X-rays, very well. It is used in medical field. So to scan the internal parts of the body, particularly bones. So gamma rays are used to treat cancers. So in the next slide, I've given a detailed application of these electromagnetic radiations, but because of this time constraint, now I'm not going to do this. Please go through them while doing the revision. Now with this brief theoretical background, now let us move on to the problem part. So let us solve the problems related to electromagnetic waves. Now the first problem goes like this. In an electromagnetic wave, the direction of the magnetic field induction B is, options are parallel to the electric field E, perpendicular to the electric field E, parallel to propagation direction, and random. Now, in order to understand this, now let us write the pictorial representation of three mutually perpendicular axes, X, Y, and Z. You know very well. So along Y, let us take electric field, and along Z, let us take magnetic field. Then the electromagnetic wave will be traversing along X direction. So therefore, this magnetic field, if you look at, it is perpendicular to electric field. So therefore, the answer must be option B. That is perpendicular to the electric field. Hope you understood. You can answer, students, you can answer in the chat box. If you are knowing about answers, you can answer. Yes, Tejas, Saujanya has answered correct. Yes, it is B. Now let us move on to the second one. So consider the following statements about electromagnetic radiations. All of them. Now read one by one. Have same velocity, exert pressure on an object, have the same frequency, undergo polarization. So look at this. We've already learned about this in properties while studying the properties of electromagnetic waves. So we knew these things. Now among them, let us check one by one. So is that electromagnetic waves have the same velocity? Yes, of course. We already told all of them are having the same velocity. They exert pressure on an object. Yes, whenever it is incident on an object, it exerts pressure on them. So have the same frequency? No, it can never be, because there will be no classification at all if they have the same frequency. They undergo polarization. Yes, all electromagnetic waves can undergo polarization. So according to this, 1, 2, and 4 are correct. So therefore, based on that, I can say option A is the correct answer. Hope you understood this. So you are giving the answers. Good that you are understanding what I'm telling. So you are giving correct answers. Thank you, students. Respond like this. Now let us move on to the third one. So which of the following X-rays is not electromagnetic waves? Look at the options. Look at the question first, which is not electromagnetic wave. X-rays, gamma rays, beta rays, heat rays. So what is this heat rays? Heat rays are nothing but infrared radiations. So remember that trick. Rich man in Vijayanagar used expensive gold. So are radio waves. So X-rays coming this wave, gamma rays also there in this group, IR rays are also there in this group. So then what about this beta rays? So beta rays is just to make you to confuse, they have given it as beta rays. Actually, beta rays are not at all there. They are actually beta particles. Remember this. So they are nothing but electrons. So don't confuse. So therefore, not electromagnetic wave is beta rays. So option C should be your answer. So I think many have given the answer. Good. Your understanding. Next, let us go to the next question. Which of the following radiation has the least wavelength? Now look at the options. Gamma rays, UV rays, visible rays, X rays. Again, remember the same trick. What is that? Rich man in Vijayanagar used expensive gold. So gamma rays, so how they are arranged? They are arranged from gamma to radio in increasing wavelength, right? So now we have to look at which is having the least wavelength. So if you look at this category, the gamma is the one which is having least wavelength range, whereas radio wave is the one which is having longer wavelength range because it is going in increasing order from right to left. So therefore, based on this, I can say clearly the option A, which is given as gamma rays, should possess the least wavelength. Therefore, answer should be gamma rays. Understood, students? Yes. So therefore, see the change. So wherever you go, you have to remember this order, either in increasing wavelength order or increasing frequency order. So in order to memorize that, we have given a trick like this. So if you know some other trick, you can send it in the chat box so that you can, your friends are also aware about that. So that if it is easy, better than this, then we can memorize like that. Okay, let us move to this fifth question. Which of the following is of longest wavelength? See, it was first least wavelength. Now it is asked for longest wavelength. The same type of question, isn't it? Yes, I got the answers. Correct. Sweetie, D. Yes, Saujanya. All are going giving the correct answers. Now let us analyze this. How? So again, you have to remember the same thing. What is that? Rich man in Vijayanagar used expensive gold. So how it is arranged? It is arranged in increasing wavelength order. Increasing wavelength order. So longest wavelength, which is the one, the radio wave is the one which is having longest wavelength, whereas gamma is the one which is having least wavelength range. In between these waves are having intermediate wavelength energy values, values. So here, look at the options. X-rays is just above gamma, gamma rays, which are the least ones, microwaves, which are just after the radio waves, but of course they are also longer compared to infrared. Last option is radio waves. So radio waves are having the longer wavelength region. So therefore, based on this category, we can say radio waves are the ones which possess longer wavelength regions. So answer should be option D. Remember students, this question will be answered based on the options given. Suppose instead of radio waves, if the options are given as visible, let us say visible, instead of radio waves, if it is given with visible, then what should be the answer? Can anyone? What should be the answer? If option D is visible, then what should be the answer for the same question? No? Yes, Saujanya, you are correct. It is microwaves. So therefore, you have to look at the options properly. So if visible is given instead of radio waves, look at the range. So visible is here and microwaves are here. They are longer than visible. So therefore, microwave waves are the answer for longest wavelength if the option D is visible. So hope you understood how to analyze this. And then it is given in wavelength order. Suppose if it is given in frequency also, you know the relation C is equal to nu lambda or nu is equal to C by lambda. Using this equation, you can get the expression for frequency also. Likewise, you can solve the problems related to frequency also. So hope you understood. Now let us move to the next problem. The wavelength of X-rays is of the order of, see, it is given 1 meter, 1 centimeter, 1 micron, 1 angstrom. Now how to judge this? So in order to judge this, remember, you need to remember the wavelength range. So someone has given us A. No, option is wrong. So let us remember the wavelength range for X-rays. So it is, go back and see the slide. Afterwards, it is given as 10 power minus 3, yes, Basappa has given 1 micron, it's also wrong. 10 power minus 3 nanometer to 1 nanometer. Yes, Joshita has given the correct answer, option D, good. So 10 power minus 3 nanometer to 1 nanometer. So X-rays are having the wavelength range which vary from 10 power minus 3 to 1 nanometer. So this 1 nanometer can be written as 10 into 10 power minus 10 meter, which is nothing but 10 angstrom unit, isn't it? So 10 angstrom unit. So with this, anything which is comparable with 10 among these values is 1 angstrom. So therefore, answer is 1 angstrom. Hope you understood this, how to judge. Yes. Now let us move on to the next question. A plane electromagnetic wave is incident on a material surface. If the wave delivers momentum P and energy E, then options are P is equal to 0, E is equal to 0. That is, P is momentum, E is energy here. P is not equivalent to 0, E is not equivalent to 0. P is equivalent to not equivalent to 0, E is equal to 0. And the last option is like P is equal to 0, but E is not equivalent to 0. Now, in order to give the answer for this, remember the properties. So whenever a light incident on a surface, you know that it possesses pressure. It possesses pressure. It creates pressure. Yes, someone has given answer B. Yes, correct. Because as per the properties of electromagnetic wave, the electromagnetic wave carry both momentum and energy. Whenever it is propagating, it possesses both momentum and energy. So if it is possessing both momentum and energy, then their values will never be zero, isn't it? Will never be zero. So they cannot have zero value. So therefore, option B is the correct answer. That means momentum cannot be zero as well as energy cannot be zero because they are having some value for them. Hope you understood this. Next, let's move on to the next question. Here. In an electromagnetic wave, the average energy density associated with magnetic field is average energy density. So there's no doing here, nothing doing here. You have to memorize this. So there will be two formulas related to this. Hope the slide is visible and I'm audible. Please give response, students. Am I audible? Yes, okay. The screen is visible, Saujanya? Is the screen visible? Yes, thank you. Now, so average energy density can be expressed in two different ways. So which are those? Let us tell. Let me write them. Energy density associated with, okay, let us go for the first, electric field. is given by half E squared into epsilon naught in terms of permittivity and electric field. Whereas energy density associated with magnetic field is given by half B squared, but here it is 1 by mu naught, where mu naught is the permeability. So based on this, for magnetic field, I can write B squared by 2 mu naught. So if you look at this option, so where is that option available? It is in option 2, that is option B, B squared by 2 mu naught. So option B is the correct answer. So here no other trick, you have to remember the formula. So one is for electric field, another one is for magnetic field. So based on that, you have to give the answer as well as you have to use them if it is asked to solve the problems. Hope you understood, students. Now let us move towards the next problem. Hope the screen is visible. Yes, can you read? Can anyone of you read? Okay, I think you cannot unmute yourself. Okay. Oh, the question is visible. Is it visible, students? Yes. Let us read the question. Yes, Ritik. If a source is transmitting electromagnetic wave of frequency 8.2 into 10 power 6 Hz, then wavelength of the electromagnetic waves transmitted from the source will be. Now you have to find out wavelength. What is given? Frequency is given. So this type of problem, you need to read them twice to analyze. So now you write the data given. To solve this, write the data given first. Yes, answers are coming. Yes, you are so fast enough to do this. Good. So frequency nu is given. Write that 8.2 into 10 power 6 Hertz. What you're supposed to find out? Wavelength. Which is the formula? It's a well-known formula we know. C is equal to mu lambda. So here lambda is required. So I can write lambda is equal to C by mu. What is the value of C? Velocity of light. It is taken as 10 into 10 power 8 meter per second. So nu is given as 8.2 into 10 power 6 Hertz. Now comes the calculation. Simplification factor. 3 by 8.2. You don't have a calculator to find it exactly. So what best we can do is we have to approximate this, isn't it? So approximation is course good in CET, not in actual exams, but in CET approximation can be done. So instead of 8.2, you take 3 by 8 and into 10 power 8. So when 10 power 6 goes to the numerator, it becomes 10 power 6. So give me the answer. What's the answer? What is 3 by 8 approximately? What is 3 by 8 approximately? If you do perfect calculation, then you will get around 0.375. Let us not go for that. You do again weight calculation live. Instead of 3, you consider it as 32, then you will get approximately 0.4. So then multiplied by 10 power 2. So this will be approximately 40. Okay. But remember this, in the denominator, it is not 8, it is 8.2, which is a little bit more. So therefore, the fraction value should be less than the obtained value. So that means our value should be less than 40. Now look at the options. Which is the value which we can see which is less than 40? So option A is 36.6. Yes, it is less than 40. Option B is 40.5. It is greater than 40. Option C is 42.3. It is also greater than 40. And option D is also greater than 40. So our answer must be less than 40. So which is the option given here? Option A, which is 36.6. So this should be the answer. So this is actually approximation method. You need to use sometimes because you cannot go for actual calculation as you're not using calculators. And you should be fast enough also. So during that time, this type of approximation can be forceful. Hope you understood this. Let us move on to the next problem. An electromagnetic wave of frequency nu which is given as 3 megahertz, passes vacuum into a dielectric medium with dielectric constant K as 4. Then, read the problem once again. An electromagnetic wave of frequency nu is equal to 3 megahertz passes vacuum into a dielectric medium with dielectric constant K is equal to 4. So that means here the wave is traveling from one medium to another. That means from vacuum to dielectric medium. So in order to find, look at the options, they are not given values. They are given in terms of sentence. That is, wavelength is double and the frequency remains unchanged. Wavelength is double and frequency becomes half. Wavelength is halved and frequency remains unchanged. Wavelength and frequency both remain unchanged. Now, in order to solve this, let us write the data given. So, nu is equal to 8.2 mega means, sorry.
Nu is 3. Nu is 3. 8.12.
Okay, sorry. Nu is 3 megahertz, that is 10 power 6 hertz. Then dielectric constant K, which is also taken as epsilon r, is given as 4. Now you need to find the relation between using these parameters. You have to find the relation which comes in options. Okay, so to do this, we know the formula. Refractive index of n, which can be calculated of root of k. So using this, k is given as 4, so we'll get 2 as the answer. But as there exist two mediums here, wave is traveling from one medium to another, we can use a refractive index relation, which is given by the ratio of velocity in vacuum to the velocity of in material medium. So that is n is equal to c by v. Hope you remember this formula. So remember, very important, when electromagnetic wave travels from one medium to other medium, its frequency remains constant or unchanged. Very, very important. Remember this. Whenever electromagnetic wave travels from one medium to another medium, its frequency will never change. So therefore, so C, we can write nu lambda. So it is wavelength which is going to change. So nu lambda 1, nu remains the same, nu lambda 2. So two different wavelengths, but same frequency. So now we'll get the relation lambda by lambda 2. Isn't it? But n you got from the previous equation as 2. Therefore, I can write lambda 1 by lambda 2 as 2, which implies lambda 2 is equal to half of lambda 1. That means whenever it travels from one medium to another medium with the above given parameters, so the wavelength is reduced by half. So therefore, look at but frequency remains unchanged. So therefore, now look at the options. So wavelength is hard or half is given in option C and frequency remains unchanged. So this should be the answer. Hope you understood this, how to analyze. Yes? Yes, students? So remember this. Okay, Ritik, thank you. Now let us move on to the next problem. The electric field for an electromagnetic wave is given as E is equal to E naught sine of pi of again 12 into 10 power 15t minus 4 into 10 power 7 x. But what is the speed of the wave? So this is the wave equation given, and it is asked to find out what is the speed, that is velocity of wave. So first look at this equation. So in this case, what you have to do is So first you have to write the standard form of wave, that is represented by the equation y is equal to a sine of omega x minus omega t minus kx. Remember this, omega t minus kx. Now let us write the given equation in terms of wave equation. So that is equivalent to E naught sine of, there will be no parameter here, so constant here. So let us send this pi inside this bracket. Then in this case, so you'll get 12 pi into 10 power 15 t minus 4 pi into 10 power 7 x. So this is same as that of y. Comparing this equation 1 and 2, we can write the relation for the angular frequency omega, that is given by 12 pi into 10 power 15. In the same way for the wave number k, that is given by 4 pi into 10 power 7. Understood this? So you have to compare these two equations and you have to write this. Now you know the velocity, speed of light is v. In terms of v numbers, you can write the ratio as omega by k. So substitute for this, omega is 12 pi into 10 power 15 and k is 4 pi into 10 power 15, 10 power 7. So simplify this, pi gets cancelled, 4 3s are, so 15 minus 7, you will get 8, 3 into 10 power 8 meter per second. Okay, for the given parameters, we got the speed of wave as 3 into 10 power 8 meter per second. So based on the value of v, particularly in this problem, can you judge which is the medium where actually the electromagnetic wave is traveling? Can anyone give the answer based on the value of v? Yes, any answer for this? Yeah? No, it's not yet. Yes, Ritik, vacuum. So free space. Yes, it is traveling in a free space. Then the velocity of electromagnetic wave will be same as that of velocity of light. Therefore, it is traveling in vacuum. Suppose if the value v is found to be less than 3 into 10 power 8 meter per second, remember, then you have to consider the medium as denser. So the wave is traveling from denser medium. Remember this. Hope you understood this. Now let us move on to the next problem. The velocity of electromagnetic wave is parallel to E cross B squared, B cross E, E, B. So in order to analyze this, let us write the wave representation, x-axis, three mutually perpendicular axis, y, z. Yes, along y, let us consider the electric field, and along z, let us consider the magnetic field. These two are mutually perpendicular to each other. Now, based on the electromagnetic wave concept, we know that E and V will be traveling along x-axis. So that is, it is carrying the velocity. So V is along x direction. Velocity is along x direction. Okay, if you consider V, the velocity is perpendicular to B alone, isn't it? If you look at these two, it is perpendicular to B alone, and the same way, velocity is perpendicular to E alone. Yes? What happens to this E cross B or B cross E? What is this actually? So this cross product always represents the direction of EM wave, that is electromagnetic wave. So remember, the cross product of these two fields always represents the direction of electromagnetic wave. So look at this. So the direction of electromagnetic is taking place along x-axis, and where we have defined a velocity also, which is taking place through the x-axis, which is directed towards the x-axis. So therefore, B cross C is showing the propagation distance, where propagation direction means this B cross E is also parallel to velocity. Can you remember? Parallel to velocity. So therefore, look at the question. The velocity of the electromagnetic wave is parallel to B cross E, the cross product of B and E. Hope you understood this. So if you take separately B, it is perpendicular to B alone. So B is perpendicular to E alone. But if you take the cross product of these two fields, which are mutually perpendicular to each other, then that represents the direction of electromagnetic wave. So then direction is taking place along the velocity. Therefore, B cross E is parallel to V. Hope you understood this. Yes. Okay, moving towards the next problem. It is which of the following is not the application of UV waves, that is ultraviolet waves. So this comes the application part. Yes, someone has given already. Treating cancer. Yes, option is correct. Now let us analyze this. How? So UV waves, as I already shown in the slide, that they are used to purify water, used to sterilize instruments. Yes, it is the main source of vitamin D. It is the main source. Sun is a natural source of vitamin D. You know all of this, isn't it? So nowadays, you might have heard of the word vitamin D. Yes, because of pandemic, isn't it? So deficiency of vitamin D will lower your immune system, because of which the recovery rate in COVID-19 has become very low. Okay, the rate of recovery is going to reduce because of the deficiency of vitamin D. Hope you are aware about this. Some reports are saying like this. So those who have got infected with the COVID-19 and having the vitamin D deficiency will get longer time to recover from the disease. So therefore, we should never go for deficient of vitamin D. So we'll easily get vitamin D. How? Just stand in front of the sun in the early morning for a minimum of 10 to 15 minutes every day. So you will definitely will not fall with deficiency of vitamin D. So remember that. So all these three are the uses of UV rays. Whereas treating cancer, the waves which are coming to treat cancer requires high energetic waves. High energetic waves. So, but UV rays are not that much energetic compared to microwaves and radio waves. Sorry, gamma rays and X-rays. So therefore, UV rays are not used to treat cancer. So option should be C. Answer should be option C. Hope you understood. Now let's move on to the next problem. An accelerated charge produces only electric field, only magnetic field, electromagnetic waves, none. Okay, now to answer this, yes, electromagnetic waves, we take correct answer. But let us think about the other possibility also. So not only accelerated charge, you have to go for different type of charges here. So first one, let us take the steady charge. Steady charge, or is also called as stationary charge. That means it is idle. So this type of charge possess only electric field. Remember this, only electric field. Whereas the charge which is moving with constant velocity possess both electric and magnetic fields, isn't it? Hope you know all this. We'll just remember both electric and magnetic fields. Now coming to the last type, that is called accelerated charge. This is also represented as oscillating charge. Or you can say it is a charge moving with Yes, varying velocity. Means velocity is not constant here, it is varying. Then that type of charge is referred as accelerated charge, or it's also called as oscillating charge. For this, it can produce electromagnetic waves. So accelerated charge can produce electromagnetic waves. Now coming to the options. So what is the question? An accelerated charge produces what? Electromagnetic waves. Remember this. Now coming to the last problem. Radio waves are used for the communication purpose because now we have already mentioned in the uses of radio waves, they are mainly used for broadcasting and communication. So why they are used for communication purpose? Now, you know that radio waves are having longer wavelength regions. Radio waves are having longer wavelength values or range. So because of this longer wavelength nature, they can easily bend, isn't it? They can easily bend across the buildings. Across the building. Because of their longer wavelength nature, these waves can easily bend across the buildings. Now, if they are going to bend, then the phenomena which is related to bending action of light is diffraction, isn't it? So therefore, they are used for communication. So the radio waves are used for communication purpose because they diffract easily. So all other options are wrong. So only because of this property, they are used for communication purpose because they can bend easily. Yes, students, hope you understood. Yes. Hope you understood. Yes, Tejas. Good that you have understood. I hope I met your expectation related to electromagnetic waves. So these are just the CET questions which I have discussed. Remember, there will be no direct displacement current concept in this for CET. So skip that while preparing for the class. Now I will leave the class. Thank you for your patience hearing. If you have any queries or any doubts or any clarifications you require, you can post your queries in the WhatsApp group so we can able to answer after the class. So we will answer. So hope you understood everything related to electromagnetic waves. And I will be ending the class now. Thank you for your patience hearing. Thank you very much, students.
Thank you, ma'am.
Thank you. Vinay, shall I quit?
Yes, ma'am. Yes, ma'am. You can quit, ma'am.
Okay.
तो नहीं बन रहा है इससे नहीं बन रहा है इसलिए फोन चला रहे हो तो
Meena, ma'am, you can start, ma'am. Hello, Veena ma'am. You can start, ma'am.
Hello, am I audible now? Vinay? Hello, students?
Yes, ma'am. You are audible, ma'am.
Yeah, okay, right. Let's start. Okay, thank you. Hello, Vinay.
Hello. ಹೇಳಿ ma'am.
ಕೇಳಿಸ್ತಿದ್ಯಾ?
Ma'am.
Audible. Yeah. Okay, I'll continue. Good morning, students. This is Dr. Veena from Chemistry Department. Today I'll be just discussing a few questions on atomic structure and periodic table. As some of the topics were deleted from your CET syllabus, like metallurgy, chemistry in daily life, and one more topic, that is environmental chemistry. I'm just redoing these, the questions from the atomic structure and periodic table just for 30 minutes, then I'll wind up the session, okay? Let us consider the first question, okay, on the from the atomic structure. Which of the following is not possible value of azimuthal quantum number, that is L, for an electron with principal quantum number 3? So the four options given are 0, 1, 2, and 3. Okay, let us see the solution. So here we must know that the n value they are asked for the L value they are asked for n is equal to 3. Okay, and we should remember that L is always less than n. Okay, the L is always less than n. So which of the following is not possible? Because 0 is possible because it is less than 3. 1 is possible which is less than 3. Yeah. Somebody is talking. Can you please repeat? Okay, so the 3 will be the answer because n can't be is equal to L. So fourth one is the answer. Okay, the energy per quantum associated with the light wave with wavelength 250 into 10 to the power of minus 9 meter is. So we have to calculate the energy of the per quantum of this quantum associated with the light wave which is having a wavelength 250 into 10 to the power of minus 9 meter. Okay, in order to calculate this, okay, let us have this formula. E is equal to E is given by the energy of this photon is given by hc divided by lambda, where h is a Planck's constant and c is the velocity of light. These two are constants, and the lambda value it is given 250 into 10 to the power of minus 9, and substitute. Okay, if you calculate this is the value you are going to get. Thereby the answer will be the first one, 7.92 into 10 to the power of minus 19 joules. Okay, there's the energy of that photon which is having a wavelength 250 into 10 to the power of minus 9 meter. The next question, the set of quantum numbers not possible for an electron, the set of quantum numbers which is not possible for an electron. Okay, so how to know this? Let us see the first one. Okay, so where the first number indicates the n value, the second one is L, Next is magnetic quantum number, the spin quantum number. Okay, just observe all the 4 options. Okay, now let us see. So the condition n should be always greater than L. L may be okay greater than or is equal to M. Okay, this condition is fulfilled by the option 2, 3 and also 4. But with respect to the option number 1, where N and L are equal to each other. So N is equal to 1 and L is also a magnet. Okay, the azimuthal quantum number is also looking same. That's why the first option, okay, is not possible. So this set of quantum numbers, it is not possible for an electron, but all other 3 possibilities are there for any given electron. So the answer is the first option. Next, which of the following sets of quantum numbers represents the highest energy of an atom? The highest energy of an atom. Students, remember the energy is calculated by N plus L. N plus L. The sum of principal quantum number and azimuthal quantum number. Okay, that will give the energy thereby. So for whichever the set you are observing, the greater value for N plus L, then that okay will be having higher energy thereby. So let us consider the first option where N is equal to 3 and L is equal to 1. Okay, N plus L value becomes is equal to 4. Okay, and the second one, 3 plus 2, it becomes 5. 4, okay, the third one, 4 plus 0, it is 4. And the fourth option, 3 plus 0, it becomes is equal to 3. Thereby, so the correct option will be where you are finding 3 plus 2, where the second option is finding higher value for N plus L, that says that, okay, that will be having higher energy. The answer is the option 2. A neutral atom of an element has 2K and 8L and 9M and 2N electrons. So this K, L, M and N, they are representing, okay, the shells, okay, the first, okay, second, third, like that, okay. So these are the number of okay, the electrons present. Okay, 8 electrons are there in K shell, 9 electrons are there in L, and okay, so M, and 2, okay, and N, 2 electrons are there in N shell. Thereby, okay, the number of D electrons in its, okay, is you have to calculate. Okay, so there are 2 electrons in K shell, 8 electrons in L, and 9 electrons are there in M shell, and there are only 2 electrons in N shell. So K shell represents the, okay, the first energy level here, okay, and the L represents the second one. M represents the third, where that includes 3s, 3p and also 3d, and N represents only the fourth, okay, the shell, so where you are finding only 4s thereby. Okay, so how many electrons are there? When you distribute these electrons according to, okay, the given condition, then so how many electrons we are finding in D? Okay, the orbital, we have only 1 electron, thereby the answer is, okay, the second option. Okay, you just remember, so we are finding only 1 electron in the, okay, the D orbital. So first of all, you have to consider this, and based on that you need to write an electronic configuration for that particular item, and then, okay, so you just find how many electrons are there in the D orbital. The option, okay, for this answer for this question is, okay, the option number 2, where you are finding only 1 electron. Next question, correct set of 4 quantum numbers for the valence electron of, okay, rubidium. Okay, let us see. So which is the correct set of quantum numbers? Okay, in order to know that, first of all, you have to write okay, the electronic configuration for this rubidium, where whose atomic number is 37, and which can be written as, okay, argan, and then 4s2, 3d10, 4p6, 5s1. Okay, so which is the outermost, okay, the shell here, the fifth one. For fifth, okay, 5s1, we have to give the quantum numbers. For 5s1, okay, n is equal to 5. Principal quantum number for 5s1, okay, it's principal quantum number is 5. And azimuthal quantum number, so you have to take it as 0 because this is a s orbital. For s orbital, azimuthal quantum number is equal to 0. When n is equal to 0, m is also becomes is equal to 0. And as we are finding only one electron, it is spinning in the clockwise direction. Thereby, the correct set of quantum numbers for this 5s1, okay, the orbital, for this electron is found to be, which is the correct answer, 5, okay, 0. And for okay, the magnetic quantum number also we are finding 0, and the spinning is in the clockwise direction. This is the correct option. Okay, now it's a very simple question. Even then, okay, you must remember this also. The orbital, okay, angular momentum, okay, for an electron is given by, so L, okay, into L plus 1, okay, H divided by 2H. So the angular momentum for an electron in s orbital is, so it is given by, for s orbital, okay, L value is equal to 0. Okay, if you substitute the L value in this formula, this is not H, this is pi. Okay, please remember. Okay, there's a mistake here. Okay, if you substitute the L value, so you are going to get this value is equal to, okay, 0. Thereby, the answer is, okay, 0 for this particular question. The orbital angular momentum for this electron, okay, which is present in s orbital, it is found to be 0. The number of radial nodes present in 3p orbitals. So we know what are radial nodes. Okay, we have discussed in detail where we can't find the probability of finding electron will be is equal to 0. So how many radial nodes we can, okay, have for the 3p orbital? Okay, in order to calculate this, so there is a formula. Radial nodes, okay, they are calculated by using the formula n minus L, okay, minus 1. Okay, use this formula, and we know the, okay, the n value for the 3p orbital is equal to, okay, 3, and the L value for this p orbital is equal to 1. If you substitute, okay, you are going to get 3 minus 1 minus 1. The resulting it will be 1. Thereby, the answer is we are finding only one radial node for 3p orbital. Now, which of the following sets of quantum numbers is correct for an 3D orbital? Okay, even though it is very easy, so just go through this. Okay, this is a, okay, most frequently asked type of question. Okay, in CET. That's why which of the following sets of quantum numbers is correct for an electron in 3D orbital? So in 3D orbital, so what should be the n value for 3D orbital? It is 3. N is equal to 2. Okay, then so here the correct set L is equal to 2, M is equal to minus 2, minus 1, 0, plus 1, plus 2. So this there are 5, okay, magnetic quantum numbers you are going to get. Then according to this condition, so which is the answer? So N is equal to 3, okay, L is equal to 2, holds good. And here, okay, minus 3 or plus 3 or minus 3, okay, these quantum numbers are not possible for 3D, okay, orbital. Thereby the correct option, so where you are finding this value for the magnetic quantum number for 3D orbital, thereby the correct option will be the third one, where we are having n is equal to 3, 2, minus 2, and s value is plus of. So this again the radial nodes regarding very easily you can calculate, and you can tell this. Okay, so the number of radial nodes for a 3s and 2p orbital, okay, you have to calculate by using the same formula, and you'll resulting with the 2 and 0. Thereby answer is, okay, the second one, radial nodes. The only thing is you should know how to calculate radial nodes. What is the formula? N minus, okay, L minus 1 will be the formula. So thereby, if you remember this, so if they ask for any of the, okay, the orbital, definitely you can calculate, okay, the radial nodes available, and you can give the answer very easily. So which one of the following sets of ions represent a collection of isoelectronic species. Isoelectronic means so which are having the same number of electrons in them. Okay, so you just go through this. Okay, definitely just by looking at the the set of these elements are ions. Okay, definitely we can decide. Okay, now to decide this very quickly, okay, it is better to know the atomic number of majority of the elements. Okay, so the answer is, so K plus is having, okay, the atomic number of this, okay, the potassium is 19, and we have removed 1 electron from the potassium. If you remove that, that results with the 18 electron. The atomic number of chlorine is 17, and in order to convert that into Cl minus, we have to add 1 electron. So plus 1, it is become 18. And Ca2 plus with the atomic number 20, if you remove 2 electrons, okay, to get Ca2 plus, we are okay. The again 18 electrons will become scandium with the atomic number 21. Okay, in order to give this 3 plus, we have to remove 3 electrons from the valence shell. So again it becomes 18. Okay, so where you can find all these, okay, that will be the correct answer. Okay, the third option is correct. Okay, so if you go through the, okay, the second one, okay, the first option, okay, it is not possible. So N, which is having a atomic number, okay, the 7 nitrogen, okay, plus 3 electrons, it becomes 10. Okay, so again 8, atomic number of oxygen is 8, okay, plus 2 electrons, it becomes 10. So fluorine, okay, that is having a atomic number 9 plus 1 electron, it becomes, okay, the 10. But what about the sulfur? So sulfur is having the atomic number 16. So if you add 2 electrons into that, it becomes 18, like that. So the other 3 options are not. You just get into this, okay, set of, okay, the ions, then definitely you can decide very quickly. Okay, only when if you know the atomic numbers of the elements. The correct option is, okay, the third one. So now X and Y are isobars with mass numbers 40. If X has 19, that's the first, okay, the atom which is having a number of, okay, the protons, 19 protons, where Y has 20 protons. Okay, X and Y are isobars with a mass number, okay, what is that? 40. If the X has 19 protons and Y has, okay, the 20 protons, the number of neutrons in X is, okay, just you have to go through this. X and Y are isobars, they are nothing but which are having same mass number. Same mass number will be same. But what about this atomic number? So there are 19 protons. So X is having, then so how to calculate number of neutrons? That is, okay, A mass number, okay, minus atomic number, which will give you number of neutrons present in X. So X becomes is equal to A minus Z. Okay, okay, A value it is given, it is 40, and also number of protons it is given 19, and then if you calculate, it becomes 21. So the correct option is second one. The angular momentum, okay, how to calculate this? Say mvr is equal to nh by 2 pi. So if you know this formula, then definitely just by looking into the options, you can mark the correct option. The angular momentum is given by, that's mvr is equal to nh divided by 2 pi, where h is a Planck's constant. Okay. Now the quantum, okay, the equation corresponding to the, okay, the wave number of spectral lines in fund series A is, okay. So here in order to recognize which, okay, the formula is correct, equation is correct, you must know, okay, when the Lyman series is formed, when the fund series, when the, okay, the Balmer series, okay. So the jumping, the if the from any higher energy level, okay, if the electrons are jumping into the ground state, okay, the Lyman series are going to form, like that. If you know this, okay, the hydrogen spectrum very clearly, then definitely you can mark the, okay, the option, okay, immediately. That is where for fund series n1 is equal to 5, n2 is equal to 6, 7, 8, etc. So from any higher energy level, if the, okay, the electrons are jumping into the, what is the fifth energy level, then the fund series is going to form, thereby the correct option is going to be, okay, 1 by 5 square minus 1 by 6 square, or into 1 by 5 square minus 1 by 6 square. The number of unpaired electrons in Ni2 plus ion, nickel 2 plus ion. Okay, how many number of unpaired electrons are there? Okay, so here you must know the atomic number of nickel first of all. The atomic number of nickel is 28. Write the electronic configuration for which first. Okay, but they asked not for the nickel atom, they asked for the nickel ion, Ni2 plus. Then remove 2 electrons from the outermost shell. Okay, that is 4s orbital. Then if you remove this the 2 electrons from the 4s orbital, then the resulting electronic configuration for Ni2 plus is found to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s0 and 3d8. There are 8 electrons in the d orbital. If you distribute these electrons, okay, that is 2 plus 2 and here 6 electrons, and there are 2 unpaired electrons. Okay, there are 2 unpaired electrons. Thereby the answer is going to be 2. Now, the region in space where, so it is a very prelim question, okay, still, okay. So I'm just, the region in space where the probability of finding an electron is highest is known as, okay, don't get confused. The highest is known as, okay, orbital, the space around the nucleus in which there's a 90%, don't, see, better not to say this percentage of, okay, probability of finding, okay, probability of finding, okay, the electron, which is called as a atomic orbital, not orbit. This answer is atomic orbital. Okay, second option is the answer. Now, the period that contains only gaseous element is, so you just assume the periodic table, okay, try to recall it, and okay, okay, you just try to give the answer for this. The period that contains only gaseous element is, the first period contains, okay, only gaseous, okay, elements. They are nothing but hydrogen and helium, which are present. They are the only two, okay, the elements which are present, and both are present in the gaseous state. Thereby the answer is first period. Now, the longest and shortest periods are in a periodic table. Okay, you must know this information also. The longest and the shortest periods are found to be, sixth period is the longest period, and okay, there you can find 32 elements, and first period is the shortest period with the 2 elements. It contains only 2 elements, whereas sixth, okay, period it's having 32 elements. Thereby the longest and the shortest, the first number should be longest, and the second, okay, the should be shortest. That is why, okay, the first can't become the answer because it is showing this the shortest and the longest. That by they are here in the question, they are represented. First you have to see the longest period and then the shortest period. So then the answer is going to be the option 3. So where the longest and represented, followed by the shortest period. Now, which of the following has both members from the same group of the periodic table? Again, the same thing. Okay, it is better to remember the overall periodic table. So which two elements they are from the same, okay, the group. Okay, the answer is magnesium and strontium belongs to the second group. Magnesium and strontium, okay, they belongs to the second group. Okay, thereby, so with the, okay, general electronic configuration NS2, thereby the option 2 is the correct answer. If you go through, okay, so they are all belonging to the different, okay, the groups, whereby the correct answer is magnesium and strontium. In the periodic table, okay, the transition elements begin with, okay, transition elements, they begin with either the scandium or zinc or copper or mercury. Okay, so from which element our transition elements they starts or begin? Okay, the answer is, it's a very well known, okay, that is scandium, the scandium. So there's a first element of the fourth period and the 3D series, okay, which is the the electronic configuration 4:3D1. So this is the first element of the transition element. I'll repeat. The answer is scandium. Now, among S block metals and transition metals, among S block metals and transition metals, which are more metallic in nature. So both are metals. S block elements, they are also metals. Transition metals, they are also metals. But among these two, which are more metallic? Which are more metallic? S block elements or transition elements, both are equally metallic or cannot be predicted. There are 4 options are given. Let us give the explanation first. S block elements having least ionization potential and electronegative value, hence more metallic. Thereby S block elements are more metallic than P as well as D block elements. So because across a period metallic nature decreases, but down the group metallic nature increases. You can conclude that S block elements are more metallic than the transition metals. The answer is S block metals. The reason it is very clearly it is given, which are having less ionization potential. That is, we need to supply only very minimum amount of energy by which we can remove the electron from the outermost shell. Thereby, they can lose the electron very easily and quickly, and you can say that with that property they are showing more metallic property, and also they are having lower electronegativity when compared to P and D block elements. Now, if the ionization potential IP of sodium is 5.48 electron volt, the first ionization energy, that's the IP of sodium is 5.48 electron volt. The IP of K, that is potassium, will be IP of K, that is potassium, will be So what is the answer? For sodium they have given 5.48 electron volt. But here they asked for the potassium. They asked for the potassium. See here, down the group atomic size increases. As the atomic size increases, our ionization potential, the whatever the energy we are supplying to remove electron from the outermost shell, that will be get decreased. That will be get decreased. Thereby, our potassium should have the lower ionization potential than our sodium. Thereby, among here the 4 values which are given, one is 5.68, other one is the same 5.48, and the third option is 10.88. As we have concluded that potassium will be having lower ionization potential than sodium, and thereby the answer you can mark it as 4.34 electron volt. So the first option is the correct answer. Now, the ionization energy of nitrogen is more than that of oxygen, because so here you should be able to identify the reason why nitrogen is more which is the ionization energy of nitrogen is more than that of oxygen. So even though along a period actually ionization potential is going to get increased, our oxygen is coming along a period, if you consider, it is coming after the nitrogen. Thereby our oxygen should have more ionization potential than the nitrogen, but there is a deviation. That is because of what the reason. Even though according to the trend, what is that ionization potential that increases across the period, as oxygen is coming after the nitrogen, our oxygen must have high ionization potential than the nitrogen. But here the nitrogen, actually speaking, okay, practically nitrogen is having more ionization potential than oxygen. The reason for which is, okay, due to off-field electronic configuration. That is, or the atomic number of nitrogen, it is 7. 1s2, 2s2, 2p3. So where 2p orbitals are exactly off-filled, so those exactly off-filled, okay, orbitals are more stable when compared to the, okay, electronic configuration of that, what is that? Oxygen. Thereby the answer is, okay, so of extra stability of off-filled p orbitals in nitrogen, our nitrogen is having, okay, more stable electronic configuration than the oxygen. That is why, so ionization energy, the energy required to remove the electron from that nitrogen, okay, from the outermost shell, it requires more energy than that of oxygen. Thereby that is due to the exactly off-filled, okay, electronic configuration, that is the p orbitals. Now, statement 1, the atomic radius of inert gases is high, okay, and the statement 2, van der Waals radius is less than covalent radius. There are two statements, okay. The first one is, the statement is the atomic radius of inert gases is high, okay, and the second one, van der Waals radius is less than covalent radius, okay. So here there are four options, okay. Both statement 1 and statement 2 are true and statement 2 is not correct. So I'll just directly go to the answer. Statement 1 is true. Statement 1 is true because the atomic radius of inert gases is very high, okay. And statement, okay, 2 is false because, okay, van der Waals radius is always greater than covalent radius. That's why the correct answer is, okay, third option, statement 1 is true, okay, it is known for us, and statement 2 is false because covalent radius is always, okay, less than van der Waals. Here are the opposite is given. Thereby the correct option is, okay, the third option. Now, which of the following element has the highest second ionization energy? Highest second ionization energy. Okay. Now, so there are, okay, the four options it is given. 1s2, helium 1s2, and helium 2s1, and the fourth option is helium 2s2, 2p1. Okay. Now, let us see. Here, the lithium with the atomic number 3, okay, that is here the third option, okay, lithium. If you remove one electron from here, this is the atomic, okay, this is the, okay, electronic configuration for the lithium with the atomic number 3, that is helium with the atomic number 2, that is 1s2, and then 2s1. This is the, okay, the electronic configuration of lithium atom. If you remove one electron from the 2s1, then our lithium plus, it will acquire the stable electronic configuration, that is of helium. Then if you want to remove one electron from this helium, that is a stable electronic, okay, configuration, then we have to put very high, okay, that is a potential. That is why, okay, the correct option is, okay, is here. So but in the other cases, okay, very easily you can remove this 2p1, and also you can remove one electron afterwards from the 2s1, okay, 2s2. Thereby, so when compared to all other three options, okay, so this is where you are applying, okay, the second ionization potential is very much high when compared to all other three options. The main reason for which is, okay, once you remove one electron from the 2s orbital, it will get the stable electronic configuration of that is helium. That is why it is very tough to remove electron from that stable electronic configuration, and hence the second ionization potential will be very high for this electronic configuration. Now, of the following elements, which one has low electronegativity? Which one has low electronegativity? So they are all belonging to the same group, okay? In a group, from top to bottom, electronegativity decreases. In a group, from top to bottom, electronegativity decreases. Okay, so here the fluorine first comes first, then the chlorine, bromine, and the the iodine. They're all belong to halogen family. Thereby, so our iodine that takes the last place of that particular group. Thereby, as the the electronegativity which is get decreased down the group, that is from top to the bottom. The answer is of the following element, which one has the low electronegativity? The answer you can give it as iodine. When compared to all other elements, our iodine will be having low electronegative value. Now, the configuration that shows the highest energy released when an electron is added to the atom is. So actually, whenever we are adding electron into the atomic orbital, the valence orbital, some amount of energy will be get released. And that amount of energy released, that depending upon how affinity offered by that particular element to accept the electron, and how much what will be the stability of the stability acquired by the electronic configuration by accepting the electron. Now the first one is having 1s2, 2s2, 2p3. so if you add one electron into this, it will just get a 2p4 electronic configuration. It will get 2p5. And here, so it will get a 3s1 atomic, so I mean the electronic configuration. But look at this, the option 3. If you add one electron to the valence orbital of this, that is 2p5. If it accept one electron, then it will become it will acquire a stable electronic configuration. That is why so if you add one electron to this particular element, then the energy released in such case it will be very high when compared to the all other electronic configuration that shows highest energy released when an electron is added to the atom is found to be the option 3. The option 3. The last question, in a period from left to right, electron affinity, whether it electron affinity, the affinity towards the electron, whether that increases or decreases or remains same, or first increases and then decreases. The 4 options which are given. The answer is, as the atomic size decreases, nuclear attraction increases and electron affinity will also get increased. So they have given along a period from left to right. What about the electron affinity? So we know that from left to right, the atomic size that get decreased, the effective nuclear charge will be get increased, and thereby electron affinity should also increase along the period. So these are the few questions, sample questions what I have selected from periodic table and atomic structure. And students, I'll just discuss. As today is the last the day of the coaching classes, whatever we conducted so far. From basic science department like a physics, chemistry, and the mathematics department, we have conducted the online coaching classes. Today is the last day of the coaching class. From Monday you'll have mock test. There are no more coaching classes. From Monday onwards you'll have 2 mock tests. And you should prepare for those 2 mock tests. I just wanted to give some information regarding the mock test. Before that, so thank you all of you for supporting us, and you attended with a full interest. So the from BIT side, we would like to say thanks for all of you for joining these online coaching classes. And with the same interest, I'm just requesting you people to attend the mock test also. I'll give some information regarding the mock test, how we are conducting these mock tests, what are the instructions to be followed by the students. All the informations I'll give. So you just concentrate on these last slides. Okay, so after 40 days of this online CET coaching and a detailed discussion of more than 1500 questions by our basic science faculty, it is now time to conduct the mock test. Okay, so thereby the mock test that is CET 2021 to be conducted by Bangalore Institute of Technology. There are 2 rounds of mock tests, and the tests will be held as for the following timetable. I'll just show you the timetable and attend the same with the full confidence and improve your confidence level. See, because of which we are conducting these online classes, and also we are making preparing you people for your upcoming KCET. Okay, that's why in order to increase your confidence level and in order to do well in your actual KCET, okay, it is very much required for you people to prepare well for this mock test. Okay, the first, and then the same confidence will level will retain even to attend your the real KCET exam. So this is the timetable which you need to follow. Okay, so first round which will be held on we are planning on Monday, that is 16th 8 2021. So for in the first round, you have 10 a.m. to the 10 p.m. You'll be having a physics, the mock test. And then from 1 to 2:10, you'll have maths, and 3:40 to 4:50, you'll have chemistry. Okay. So all the three, the subjects mock test will be, you'll be having both on Monday as well as, Wednesday. So Wednesday is also the same timings, that is 10 to 11, like math 10 to 11:10. Okay, maths will be having 1 to 2:10 chemistry, and 3:40 to 4:50 you'll be having the physics. Okay, the same timetable will be circulated in your WhatsApp group. You can follow that. Okay, and next the very important thing is what are the instructions to be followed by the students. Okay, so test starts as per the timings given in the timetable. Whatever the time just now I mentioned, the same time will be followed. The Google form link for the question paper will be shared 10 minutes prior to the test, not more before that. Okay, time in your respective WhatsApp groups. Okay, open the question paper by clicking the link. Be ready with the stationaries like pen, pencil, and few white sheets just to do the workout over there. Okay, fill all the required fields in the Google form. You have to fill all the necessary details in that Google form and start answering. Okay, do not use calculator or any other electronic gadgets for the calculation purpose, including your, see, by default your hand goes to your mobile. Okay, so you should not use that also. Okay, you should not use a calculator from your mobile also. Okay, do not refer to your study material. So even though the books are in front of you, please don't refer. Okay, so without taking the help from your books, you need to answer all the questions, answering the questions. Remember, you are actually testing your preparation level using this platform. Okay, so you should not show how you are prepared for anybody's. Okay, so you have to increase your confidence level. In order to increase that, so you need to follow these instructions. Okay, hence be honest and sincere in your attempt. Okay, honesty is the best policy, so it is very, very important. Okay, all the questions are mandatory. Okay, all the questions are mandatory, so answer all. Okay, otherwise you cannot submit the Google form. So if you don't want to answer for a few questions, then you will not be able to submit your Google form. That is why answer all the questions. Okay, it is mandatory. Stop answering exactly after the stipulated time and submit the form. Even though, so we are not able to monitor, nobody is going to tell that stop writing and all. Okay, you should see that the time, and then you have to stop writing exactly after the stipulated time and submit the form. Okay, We will give 15 minutes extra time by considering that poor or improper network issues. Just to accept the Google form, we will give 15 minutes relaxation time. Okay, that's why you can make use of that if really, if you are not having the proper internet connection and all. If everything is good, then you can submit within time. Okay, we send the performance score on the same day. Okay, you need not wait for 1 week or 2 days or 3 days. So we are sending the performance score on the same day. Okay, you can see your score, correct answers, and also explanations for the selected questions. Okay, so you'll get the answers with the solution for the whatever the question paper we are giving for that mock test. Okay, make sure that your mobile is fully charged and the network is available, because so by mistake, if you are not going to charge your mobile, so then definitely you're going to find difficulty in answering all the questions. That is why please take care of that thing. Okay, you charge your mobile well in advance and see that you will have very good internet connection. Okay, so with these instructions, I just say wish you all the best. Okay, do well in your mock test. Okay, and extend the same thing for your the actual CET exam. Okay, so today just we are winding this online classes. Okay, what we conducted so far, and we'll just meet during your the mock tests. All the best, students. Thank you. Bye bye.